welcome to Edison Open House Transport Futures 2021. Now in this session, we're showcasing something a little different. We're showcasing a company called Tirupati Graphite, which is involved in providing flake graphite and graphene manufacturing. Join me is Shishir Padar, Executive Chairman. Shishir, welcome.
Thanks a lot, Vivian. Great to come to you and have some words about what we see on the future of mobility.
Now, we've heard lots and lots and lots about other minerals and metals. We haven't heard anything about graphite, but I know that you say that there are no eco-friendly vehicles of the future without flake graphite. So tell me, first of all, what is flake graphite and why is it so important?
So Vivian, flake graphite is an allotrope of carbon, and it's got a very special structure, the molecular structure, that makes it quite unique in a set of properties that it has. And there is no material that we have seen which has that diverse set of properties. Like, it's a non-metal, but it is a good conductor. It is stable at up to 3,600 degrees centigrade. It doesn't react with any acids, any chemicals. It's absolutely inert. It's got very strong heat resistance. So, a fantastic combination of properties, I would say, which makes it a material of choice in many, many ways. That's the importance of graphite.
So what we use in our lead pencils turns out to have these extraordinary properties. And yes, where is it used in the green economy?
So Vivian, the energy storage, which has been the clinching factor for us to be able to come to, electrification of mobility. If you see historically, energy storage has had many forms of batteries. Today we are with lithium-ion batteries. No form of battery except the lead acid battery is made without graphite. So it is the material which is used in every other form of batteries. Coming to lithium-ion batteries, there is more graphite in a lithium-ion battery than there is lithium. It is the single largest constituent of that, energy storage device. Point number one. Point number two, flame retardants, longevity of materials used in vehicles, the braking systems or the friction materials used in the vehicles. They all require high quality flake graphite variants, in different formats. And all this goes into an eco-friendly vehicle. A vehicle should also have, lead reduced fire hazard. In today's world, the best of flame retardants are made out of graphite. They are non-toxic. They suppress the fire in the first place, before it can occur. And if at all it occurs, they also help in extinguishing it faster. So overall, graphite has a lot of contributions in mobility. We're talking of electric cars, but if you look at other forms of mobility, graphite and graphene are expected to play a very vital role in reducing the weight or the tail weight of every form of mobility equipment, including cars. Once that happens, it will become even more and more stronger. So I think it's a material that we must all be conscious of, and we must all be looking at if we are conscious about mobility reducing emission.
That's fascinating. And I suspect there are a lot of viewers who are watching this saying, who knew that there was more graphite in a lithium-ion battery than lithium? But let's go on to graphene, which you mentioned there. I mean, wonder material, and of course, produced from graphite. And I think I'm right in saying that the quality of the graphite is critical in terms of the properties of the graphene. And just to remind everybody, graphene is kind of just a single layer, isn't it? A tiny sort of one atom thick, taken from the graphite. And once it's at that nanoscale, it has really quite different and quite extraordinary properties, which is why it's being hailed as this wonder material.
Exactly, Vivian, you've hit the nail on the head. So what happens is, we talked about graphite's exclusive properties. When you go nano, and that to a single atom or a few atom layer thick, these property gets super enhanced. You've heard wonder material. Why? It can take the load of an elephant on a needle point. Such are the things we've heard historically about graphene since it has been discovered. Similarly, on the conductivity side, it is the highest conductivity material we've ever known. So, what happens is when you go to those single, 2, 3 layer atom or few layer atom thick graphene platelets or graphene products, these properties all get super enhanced. What is the opportunity then on this? I'll take an example of something that we had been working on and we have achieved recent success. Aluminium and copper are 2 types of conductors. Aluminium is not as good a conductor as copper, but it is lightweight. So we thought, can we combine the conductivity of graphene with aluminium so that it comes closer to copper? And we worked on that and we achieved success. In fact, this is quite exclusive, I guess. Now, such material evolution of new materials for the new age, where we are so conscious about the fact that we need to reduce emission, is the key. And graphene is the material that can play a huge, huge role. Apart from the conductivity, it also has the highest strength. So, combination of graphene in composites with other materials so that you can decipher new age materials which impart higher strength with materials, say lesser weight or lesser cost or lesser resource, impacting. You evolve materials which have a longer chain of lesser emission and which, once going into mobility, will contribute to lowering emission. Let me take another example then. If you could replace copper that is used in an electric vehicle, say the Model 3, you could reduce the weight of that car by possibly about 100 kilograms, which means you could actually run that car with the same battery pack at least 10 to 12% time more. So your range increases and all these benefits you get. In addition, Vivian, in the evolution of new age energy storage, when we talk of batteries, ultimately higher we can increase the charge density and more we can reduce the charging time of batteries, more efficient the use of storage energy or stored energy will become in the future of mobility. Even in this area, while there are other areas of research ongoing which are not related to graphite or graphene, but a lot of activities are going to use these materials to improve these parameters of a battery. So I think the evolution of new materials for all these objectives, graphite will have and graphene will have quite a big role to play.
Because we've seen a huge hype around graphene. And for a while, there was the hype, there was the Nobel Prize, and really you didn't see actually any practical applications. But here you are, producing very high quality graphite and graphene. And here are the real world examples of how graphene can be used.
Yes, Vivian, and I would not say it's only us. A lot of research centers, companies have been working on it. Obviously, when a new material is discovered and it evolves, it has its timelines. On my views of what has happened over the last, say, 10 to 15 years when we have been working on this. So there were a few very important technological and qualitative bottlenecks and cost bottlenecks that needed to be overcome. That's what we have been doing as a globe on the research over the last few years. What were those bottlenecks? The process of manufacturing graphene, its scalability and the type of process. When I say type of process, conventionally, what has been most widely used is what is called the Hummer's process or its variants, which is actually a very stringent chemical treatment process in which you're trying to break apart the atomic layers of graphene in graphite. That actually left a footprint of the chemicals itself on the graphene products. And that footprint actually made it difficult for the graphene to combine with other materials. Graphene is not a material that you use in isolation or as a single material. You use it in combination with others so that you can impart its strength to the combination. So these were the bottlenecks. In fact, I can very proudly say, for that matter, that we identified these bottlenecks and we worked on developing a process that can address them. The result was that we developed a zero chemical process. We developed a scalable process and which is cost effective. There are others also who are trying to do this and there will be continued success. I see over the next 5 years, graphene is going to now, its use is going to increase by the day, by the month. There are various reports in public domain which expect the rate of growth of commercialization or commercial use of graphene to be more than 20% CAGR per annum. So my opinion is it could be even higher. And if we succeed in what we are trying to do, I'm sure we'll make it higher. So, it's something that has taken its time, but it's matured now.
So you have these very high quality graphite mines or graphite sources in Madagascar. Yeah. And tell me a bit more about those, and then how you, do you manufacture a graphene and graphite substances on the premises, or do you ship back to India?
Let me give you an overview of the entire gambit of graphite and graphene. So we have our primary projects in Madagascar. Ultimately, flake graphite it comes out from Mother Earth. It's a resource. Madagascar boasts of some of the world's best quality graphite deposits. In certain regions, it is also conducive, by way of logistics, by way of availability of water and other resources that you need. And our projects are located in those areas. What we do in Madagascar is we mine the resource, which has a few percentage points of graphite, and we process that to a degree of about 96% purity. And the second important factor in graphite is the flake size. So, it's in the form of flakes like mica. It's small, thin flakes. The size of the flakes is very vital because that means bigger the size, better the quality. You can draw a synonym with diamonds. Bigger the diamonds, rarer it is, and better the crystal structure. Same as with graphite. That is what Madagascar gives. So what we do in Madagascar is process it, mine it, process it, take it to this level of purity. And this graphite is good to go in many applications. So in all, graphite has more than 150 applications. 70% of the total graphite used. This graphite that we produce in Madagascar is good for it. The rest needs further processing into materials that get finally into the lithium-ion batteries or into the flame retardant applications or into the thermal management sheets that are used in your iPhones, in your iPads, in your laptops, and similar very high-tech products. For that, it needs very intense processing. It needs very high-end human resources to do that. It needs certain inputs which are not available in a country like Madagascar. So we are doing that in India. And I can also say, Vivian, that we are possibly one of the only or one of the 2 or 3 companies in the world which do all the types of graphite for every type of application, which is very diverse. In India, we process it to high purity, which is kind of up to 99.95 plus. Then we modify its structure for applications like I mentioned before. And then we also are setting up the graphene facilities here. For graphene, you need to use a ultra high purity graphite, as we call it. So closer to 100. If it is 99.99, the more the merrier, the better. That kind of graphite we use to manufacture graphene, and that too is in India. So because of the quality of graphene, graphite that we get from Madagascar, we have tried other sources with our same process, and we have observed that the Madagascan graphite did give the top end graphene qualitatively. So it's all panned out very well, I would say.
And what are the global supplies of graphene, graphite like? I mean, is it an abundant substance?
So over the last 10 years, Vivian, there has been a lot of exploration on graphite. That's because of the advent of the energy storage application. In this period, we have found a lot of graphite deposits in African continent. We have found new deposits in Canada. We have found some in South America. We have also found in some other locations. Madagascar has evolved also. Madagascar has been producing graphite for 100 years plus. But with companies like us going there, we've seen new resources coming out there. So I can say that you're right, that there is enough graphite in the world. We don't have a dearth of graphite. Historically, as far as the industry has gone, over the last 3 decades, China has been the largest producer. More or less as of today, about 65 to 70% of the global current production comes from China. Historically, apart from China, India, that is where I originate from, and that is where I learned. I did graphite for the last 30 years. Brazil, Madagascar, and long back, some European nations. So Scandinavia had a couple of projects. We had a project in Germany also at one point in time. So this is how this dynamics is. But now I see this evolving in a manner that there would be new capacities coming up in primarily in Africa. We need diversity of source, and I can say that the graphite from African sources, from Canadian sources, is qualitatively better than what we have been using until now. So it will evolve like this, and we have abundance, but it's not an easy industry. It's not like this that you can just go and dig there and ship it anywhere in the world and it's good enough. It's not like that. Graphite is an industry where there's a very, very deep learning curve, and we are one of the companies which is which has gone very deep in that curve. I personally have been in graphite for 30 years. Our team has collectively 150, 200 years of experience in the space of working in graphite. So yeah, these are the differentiators we have.
So there is a graphite past and there is definitely a graphite future. I mean, this now is being driven by environmental concerns. ESG, environmental governance, has a bigger and bigger part to play. I mean, obviously, as I said, you're doing this, the whole battery push is environmental in nature. But what about your own ESG credentials? Do you find that investors are wanting to know more about them before they invest?
In fact, Vivian, I'm very happy to note that the extent of consciousness that has come, not only in the investor community, but the entire globe. 10 years back, when we used to talk of climate change, then we thought it was for our next generations. Today, I think many of us realize that it is not too far away if we do not take steps. It is a necessity for the globe to minimize, emission, get to the Paris Accord, numbers, and ensure in the minimum time that we reduce our emissions. It's a necessity for our survival. With this, ESG or environment, protecting our environment, the sustainability part, and governance in relation to corporate ethics and corporate style of functioning. These are very vital. We have been, seeing more and more people asking us about our ESG quotient. In fact, we have been accorded the green mark by the London Stock Exchange when we listed in December. We are very strong in this, Vivian. And I would think that every company must take this more seriously than they ever have. We continue to think about it by the day and evolve themselves with this, that it is your responsibility to minimize impact on the environment, make your operation sustainable in every sense of the word, and be well governed. Just to give you for a few examples on what we have been doing on that side. Of all the publicly reported graphite production in the world, we have the highest recovery, or at least maybe the top 5 or top few. This is very important and useful. You're talking of resources which are finite. That comes out from Mother Earth. Say if you mine, say 100 tons of graphite ore, which has say 10 tons of graphite contained in it. When you process it, you must recover as close to 10 as possible. Our recoveries are plus of 85%. We are kind of 90% close to that. And our target is go to 95. I have seen reports which say 65%, 70%, no more than that. I have seen, these are not reports, but this is my experience. I have seen a lot of graphite operations in China, and it's bad. You are losing a lot of graphite in the tailings. This is injustice to the resource, which is finite. First point. Second point, when you mine, do it responsibly. When I say do it responsibly, you cannot get a resource unless you mine. You don't have an alternative to mining a resource. However, you can take steps that will minimize the impact of that mining. Plant more green cover than you necessarily need to remove. Minimize your waste, or as we call it, waste to wealth generation. Can we do that? We developed a new technology in our processing, which is being used in Madagascar, where we get 50% of our waste as a byproduct in the form of construction sand. Now see what this has done. On the one side, it has reduced our waste by 50%. On the other side, being used as a construction sand, you are reducing the mining of sand from riverbeds. So it's a dual impact. Such are the things that companies need to think of. Let me come a bit on the sustainability. So we look at sustainability in a very holistic way. It's not only about our societies around us. It's about sustainability in every form, whether it is the people around us, whether it is value creation, whether it is sustainability in operations and its continuity, in all forms. And on the social connect side of our company, I must say, we have brought smiles on the faces of hundreds and thousands of people. When I first went into Madagascar, it was a very sorry sight. People didn't have enough clothes on their bodies. Today, they have televisions in their houses, people who work for us or who are around there, because we have created earnings for them, not only by our own employment, but otherwise. We interact with the societies very strongly. We built a school, we built a health center 24/7 with free medication. We built a lot of infrastructure, more than we would need only for our operations, so that villages that have never been connected to the outer world, they get connected. Loads and loads of things. And we are also been working on children. On the governance side, Vivian, we have a very strong board with only one executive, myself, and rest 4 members as non-execs. We have all the committees that you should have, overlooking the functioning of the company. We have all the policies that you should have, or you are expected to have, to be a well-governed company. And we implement them by spirit, not only for compliance with the requirements. So such is the ecosystem we are trying to develop, and we continue to evolve.
I've got one final question for you, and briefly, if you would.
Yeah.
What do you see as a future vision of transport? What would you see you envision in, say, 10, 15 years' time?
So, Vivian, I think
obviously it's got lots of graphite in it.
Yeah, and more advanced materials where graphene is involved. I would see extensive use of stored energy, and that stored energy being derived from renewable sources. I would like to see improved energy storage systems, so that your mobility adaptation to energy stored or stored energy mobility increases. I would like to see the costs of this becoming affordable, like the other alternatives that we have been using historically. And the last, I would like that to see a lot of new age materials coming into the space so that they provide more efficiency to the transport of whatever materials, sea, air, road, anyways.
That's been a fascinating discussion with you, and good to have your vision of the future, which, as I said, definitely contains graphite and graphene and lots of it. Thank you so much for talking to us.
Been a pleasure, Vivian. Thanks a lot for connecting.